The last thing I'm going to talk about are some properties of the real numbers. It's important to note that these are true for all numbers. They're true for integers, fractions, counting, natural numbers, whole numbers, everybody. So we have a couple identity properties. And there's an identity property of addition and an identity property of multiplication. And what it is this. It says there exists a real unique number 0 such that a plus 0 is 0 plus a is a. So basically, this additive identity, 0, says I can add anything to 0 and I'll get back my number itself. That's pretty cool. For the multiplication identity, it says there exists a unique real number 1 such that any number times 1 is just itself. And 1 is called the multiplicative identity because 1 times anything gives us back itself. Okay? That's why we call it the identity. When we're multiplying by 1 or we're adding 0, our number remains unchanged. There are also additive and multiplicative inverses. Okay? So additive inverse we talked about earlier, right? Additive inverses undo each other. So the additive inverse of negative 3 would be 3 because their sum is 0. The additive inverse of negative 5 halves would be positive 5 halves because they undo each other. So that's the additive inverse. There's also the multiplicative inverse, and that's what we call, sometimes it's a reciprocal, but it's really just a divided by 1. So if I have a number like negative 3, and I want to multiply that by its multiplicative inverse, that'd be 1 over negative 3, which gives me negative 3 over negative 3. So I get back to 1, which is our multiplicative identity. The same is true for not so fun numbers like the square root of 5. Square root of 5 times 1 over the square root of 5, because we multiply numerators, right? I just have the square root of 5 over the square root of 5. That cancels out to 1. So that's how additive and multiplicative inverses work. I went over that. Cool. One thing that's also important to know about addition is it's commutative. Changing the order in which we add numbers doesn't change the sum. If I add 7 to 2, that's the same as 2 plus 7. I'm sure we can all agree to that. It's also associative. So it doesn't matter how I group my numbers. If I have 9 plus 7 plus 2, that's the same as 9 plus 7 plus 2. 9 plus 7 is 16, plus 2 is 18. 9 plus 9 is 18. So it's associative. Addition is commutative and associative. Multiplication, right? We already talked about the multiplicative property of 1, but let's talk about the multiplicative property of 0. It's really kind of neat that any number times 0 is always going to be 0, no matter what that number is, whether it be rational, irrational, an integer, we're always going to get back 0. We've talked about the multiplicative property of 1. Any number times 1 is itself. Multiplication is also commutative, and it's also associative. I'll leave it to you to come up with your own example to prove that to yourself. But what's really cool is it's also distributive. If I have 2 times 4 plus 5, that's the same as 2 times 4 plus 2 times 5. Let's test that. 2 times 9 is 18. I didn't do that on purpose. 2 times 4 is 8, plus 2 times 5 is 10. That's 18. So multiplication is distributive. We talked about the division property of 1. Friendly reminder that you can never divide by 0. It breaks all of mathematics. I lose my job. It's very sad. And when you used to ask Siri, when Siri first came out, original Siri, if you could divide by 0, she would say, imagine that you have 0 cookies and you split them evenly among 0 friends. How many cookies does each person get? See, it doesn't make sense. And Cookie Monster is sad that there are no cookies and you are sad because you have 0 friends, which I thought was really kind of funny.